overview of what we are doing today. First, I'll try to enlighten you on the term digital longevity, and we'll cover some aspects on why it is important to have digital projects that last. I'm going to try to tell you how you can achieve that by the ending principles and by user-centered design. And then we'll dive into a case study, the Stadt.Geschichte.Basel project, public history project in Basel on the history of the canton of Basel-Stadt. And I'm going to tell you what we do as research data management team and as public history team. And I'll hope I can give you some best practices and demonstrate some tools and workflows that we developed during the past 2 years. What is digital longevity? I guess this is what ChatGPT or DALL-E imagine will happen in the future, that there's some people uncovering 20th century digital artifacts and they have no clue what to do with it. And I'm sure we already experienced this in our lifetime. If you still have some floppy disks at home, or I guess even old USB sticks or whatnot, then you already face the problem. And if you worked on an old version of Microsoft Word or Excel and tried to open it, and if you even try to run some macros, then you're in hell, definitely. And so digital longevity, also known as digital preservation, refers to methods and practices used to ensure that digital information, such as research data, remains findable, accessible, interoperable, and reusable, fair over long periods of time, often spanning decades or even centuries. I'll shortly say a word about fair, even though I assume that you already know, like the findable, accessible, interoperable, and reusable principle should make data sharing and reusability in scientific research more easy. And it already covers a lot of what makes the digital project having these properties that we are going to talk about when it comes down to digital longevity. But one of the really important aspects for me is that if we talk about findable, we talk about human and non-human actors alike. So we don't only need to think about what the archaeologists in the future will find, but also what their tools will find. And there's a lot of stuff that only makes sense in the fair values that have to do with the present. Like it only can be interoperable today. And you cannot know what in 10 years' time people will use. So why is digital longevity important? Easy answer, the funding agency says so. You won't get any money if you don't make a data management plan. So everybody writes a data management plan. But the more complex answer is that ensuring research data is fair and preservable is expensive and time-consuming. And if you think at the start of a project, it becomes less expensive. Like it's still expensive, but it's less expensive, by a lot. I have this quote from 𝗟𝗲𝗴 and 𝗟𝗲𝗴𝗶. In a print ecosystem, many immutable copies of an object are distributed globally and are curated by a network of organizations. The key to maintaining usable analog artifacts is to ensure that they stay the same over time. Digital objects, in contrast, require active management in order to continue to be easily accessible over time. Software requires patches and updates. File formats can become quickly obsolete. as the environments around them change. And this is really a game changer also in terms of how institutions can help us with our research data. Because most of the institutions, libraries, archives, they're used to the analog world, and they are in transition to more digital archives, but they are not there yet. So we are most of the time not alone, but with little help in terms of how to do it. And there's not yet an infrastructure that is, I mean, globally or commonly accepted in terms of how to store your research data, or what even is meant by the term research data. And there's another interesting fact about the digital artifacts. Another quote: "It is commonly assumed that storage media will be the most expensive aspect of digital preservation. It's much more likely, however, that the major cost center will be the need for human intervention and expert judgment in processes like transforming and migrating objects and metadata over time, and in devising legal frameworks for rights management." This is an interesting thing if you think, for example, of large language models and of deep learning and training. Because at the moment we think, yeah, this is no problem. We have this fair use regulatory framework in the United States, but I don't know if they're still allowed to scrape everything in 10 years. And you might be in the position of offering data, but then you don't have the adequate license. So you need to change your license afterwards. And this is something that we need to think of also already now. Like, how do we want our data to be used or not used or misused in the future? And this is really hard. Like, it's something we need to think about, but it's also an unresolved issue. So what my device is looking at the ending principles and at user-centered design. Now, what is meant by ending principles? Ending principles are principles regarding data management, documentation, processing standards, product development, and release management. And they are adapted from the Endings project that I will talk about in some minutes. What is meant by data management? It's meant that you store data in an open, processable format with version control and ongoing validation. This is quite easily achieved. Like, use text-based file formats, use comma-separated values instead of Excel files, use Git or some other versioning system, and do also store some hashes or whatever you need to actually make sure that the file integrity can be validated. Like, Git automatically does this stuff for you, so just use Git. This is what I really urge you to do. And clearly document data models and intellectual property. Aim for open licensing where it is possible. And I know it's not possible in a lot of projects because you are using sources that are copyrighted, and you don't even know the status of the sources, legal status, whether you can use them or not, whether you can publish the data or not. But as long as you describe all the stuff that you have done with the data, how you came to get the data, it's a lot easier for the people in the future reusing your data, because provenance of data has already become a huge issue. If you look at the data set that are used to train large language models, we have no clue where the data comes from. Like, it's 800 gigabytes that what Llama was trained on, and it's just called big text. I mean, come on, guys, you can't be serious. And processing standards. When you write and maintain processing code, you usually do this in an R script or a Python notebook, and you discard it afterwards because it's hacky and you just put in some variables, and it ran fine on your machine, but it probably won't run on a continuous integration system. But it's really important that you look at the software you use to transform the data afterwards, and that you actually document the software. We even go so far that for our R script, we freeze the whole environment, because if you don't have the right version, you probably won't be able to reproduce what we did with the data. So this is like a lot of work for no apparent reason, but you will be glad in the future, like even future, you will be glad that you put some effort into the documentation. Yes, and it's really hard to think in terms of continuous integration if you are doing research, because you have no clue where you're going with this data, whether you use topic modeling or some other approach, and in which format you actually need your data to be in. But I urge you to have a certain point in the project where you try to implement continuous integration. It's usually when you publish your results afterwards. Like you can't do it before. It's impossible, or you're going mad. But try to do that, and try also to think in products. Like if you already know that you're going to publish the software and the data, and if you know that you're putting it on your CV, you might be putting more effort into that. And I really urge you to do that, that in the future, we get some credit for publishing data and code. Because at the moment, at least in Switzerland, it's not that highly regarded, but I hope this will change in the near future. If you create products, don't use server-side dependencies. Use standard stuff. Use legacy technologies. I know nobody wants to hear that. Everybody wants to work with Vue or some fancy new framework. But in the end, HTML and CSS, you will be able to open it from a USB stick in 10 years and it's still running. So try to build products that allow for graceful failure. Like when you build products and the search functionality is not working in 10 years, it's not a biggie. But if you can't see the records, that's a biggie. So think in terms of how the software, what are the main components that need to survive in 10 years? And for example, in our project, we are developing two different products with different end of lives. And the one fancy product has an end of life end of 2025. And the not so fancy one with legacy technology is supposed to survive 10 years. And this is the choice you make. Like, do you want to have a fancy presentation layer that might be cool for the conference, or do you want people to be able to access it in 10 or even 15 years? Then release management. This is also something that we almost never think of because we don't think in terms of software engineering when we do our products. It's more like a prototype. We hammer it out, people get to click on it and get to try it out, and then it ungracefully dies somewhere on an old unmaintained server. And in most cases, the server is somewhere at your at the last research institute you worked at, so nobody really knows what is going on. And if you think in terms of release management, there might be the possibility that some kind of research software agency or unit at your university can actually maintain what you build. But this is only possible if you have a release management and if you think in terms of who is going to maintain it after I leave this institution. So the endings principles were a research initiative by the University of Victoria Library. They faced the problems of having 15 years of under-DH projects and thousands of projects that were at risk of dissolving because of the limited time span that you usually get when you get funding. And they had a multidisciplinary team with people from faculty, programmers, and digital librarians from various fields that work together on bringing TH projects to closure, on also preserving dynamic features of projects, because most of the time we want some dynamic features to survive, and identifying suitable archival repositories. Because usually for smaller institutions, it's not feasible to set up long-time archival software. Like it's really costly. So I'm not sure about Germany, but I think there's also the strategy that with NFDE, this should be somehow concentrated at certain spots, like how you archive or long-term archive your stuff. So they developed these strategies, and I think they're really, really nice strategies, but they're only technical. And this is a huge problem because you do have users, and users on both ends. First of all, you have data producers who are going somehow to use your infrastructure. You never work alone. There are several people compiling data and working on the code and stuff. And you also have some kind of end user, even though most of the time it's an imaginary end user because we don't have yet people reusing the stuff that we built, but there will be future users. So understanding user needs, rapid prototyping, iterative design and testing, multidisciplinary approach, continuous evaluation, and accessibility and inclusion are really, really important for your research software. And last but not least, user feedback. Understanding user needs, you usually do that by conducting interviews. Like you can also send them forms, but it really helps to talk to people and watch them, how they do what they do. Like I had to survey the researchers in my project, and it's more than 80 researchers. And it was really hard because if you ask them, do you use the computer regularly? They all told me, no computer. I'm a historian. I don't do computer. And then yeah, but what do you do when you enter your office, and what's the first thing you do? Yeah, start up my computer. Okay, now we're getting somewhere. And then what? Yeah, Outlook. Okay, and then the browser. And you really need to talk people through all these steps because they have no clue how they're actually working. They have this image of how Ranke was working 100 years ago, and they're working differently, and they don't want to be called digital historian because they are the guys with the big archival boxes and not with the sleek Apple devices. But I think this is something that you only find out if you look at the people in their native habitat and watch them closely. So develop prototypes can really help. And the prototypes, I'm serious, you can even build paper-based prototypes, or you can fake the ChatGPT experience and just set up a Zoom chat and tell them you're chatting with a machine. What do you expect the machine to do? And then you see what they want from the machine, and you can think, or you can try to build it or think in terms of user requirements. And you really need to repeat this cycle, because once you think you understood the user need, you build something and then you realize, no, I have no clue. I got it all wrong. People are using the tools differently from what I imagined. And not only involve designers, but also UX experts, engineers, developers. This is also quite important. Like if you have a software engineer, call them early. Because otherwise it's going to be a hassle, because we have this one path dependency that is really hard to implement. But if we had known a year ago, it would have been so easy to circumvent. So in terms of cost efficiency, try to include everyone as soon as possible. Only actually build stuff that relates to a user need, and think of accessibility and inclusion, and not only as a feature for the funding agency, but also it makes your product better, usually. Because then you think in terms of, okay, what would a person that can't see red or green do with my interface? This is like a really common case. It's the most common seeing impairment, and mostly men are affected. So you are excluding certain groups, and usually you also have like accessibility also gives you some idea on how to structure content. It's not only visually, it's also logically. It really helps to structure content. So look at it. Regularly ask for user feedback. It's also nice because usually people love what you build, and it's nice to hear that. Just ask them. And I think that with the ending principles on the technical side, and with user-centered design covering the human aspects, you get digital longevity, or one version of it. I know you can achieve that also by different means. So Stadt.Geschichte.Basel, it's a major historical research project. It runs from 2017 to 2025. We have more than 80 researchers studying the history of Basel from the beginning of the settlement, archaeologists to the present day, contemporary historians. We are spending almost 10 million euros from the canton of Basel-Stadt and some other donors. And we have the luxury of having a team for research data management and public history of 6 people now, exactly. Like it's really, really nice to have a team working on this and not being the lonely soldier trying to motivate people to actually do it. And the output of the project are 10 printed volumes and a digital portal. And the digital portal is supposed to do this. This is an excerpt from the contract between the canton and the foundation. And it says we should do an online portal. It is designed as a virtual repository that provides public access to a wide range of data on Basel's history. The portal will be designed and organizationally integrated in such a way that it can be continued and continuously updated after the end of the 8-year project period. The continuous public visibility and the dialogue with future users of a city history are important concerns of the project. And this mission statement somehow was not reflected at all if you look at the funding and the budget. Like we got money to do a prototype and not to implement some long-running whatever this is supposed to be. So I thought, okay, we need to do something that can die after the funding runs out, but dies gracefully, so that people don't notice that we cannot accomplish this mission. And I also got some work packages from the application Stadt.Geschichte.Basel Digital, like the funding application, that we are going to do research data management, and we're also going to do public history, and that we are also trying to integrate all available data pools and whatnot. And this is also very typical for people that write about digital projects that have never done a digital project. Like it's an imaginary unicorn that you can make fly and swim and whatever, because it's semantically so flexible. But if you actually have to build and implement it, you will figure out that you can only accomplish so much. And we focus on research data management and on public history. Research data management, I'm not going into too much detail, but we are trying to preserve some of the project's artifacts according to the FAIR principles. And the problem is that research data management is a term that was coined by psychology mostly. It came from the reproducibility crisis in the 90s. And it has a lot, there's a lot of best practices for social sciences and for natural sciences. But what do we mean by research data management in historical sciences? Thorsten Hildmann from Berlin, he says, what is missing in the historical sciences, however, is an awareness that we are not only working with digital or digitized text, images, object descriptions, etc., but also with data. Also, the subject-specific recommendations for dealing with research data are available for subjects such as biology and psychology, or even for educational science, but not for historical science. He further says, while the narrower term actually included only data generated in the concrete research process of the individual project, such as the text annotations or metadata, the broader term also included the sources underlying the historical research process as a whole, as they are scientifically processed by libraries, archives, and museums, and thus made available for potential use by researchers. This is a huge problem for us. Like, who is actually taking care of the sources? Is it the archive or is it us? Because for us, the sources are the data most of the time. And do we only link to the archive in the hope that the archive will preserve what we find important, or do we have some kind of redundancy, or how do we tackle this problem? Because it's not so clear what is meant by research data. So in our case, I ask people what they think is important research data, and most of them work with text data and images. And then tables, interestingly, also really, really important. And everything else is scarcely used. They use data to write text, or let's say sources and source criticism and stuff like this. Also maps and network analysis, and some quantitative analysis. They use PDF software and, interestingly, also spreadsheet programs to annotate sources. This is what people do. Like they open up Excel and they do whatever they can with Excel because they know this tool. And afterwards, you have to deal with Excel sheets with like random data in it. And usually they also don't like to work with literature management software. Like even though it's really easy and they have had training and whatnot, they just don't like it and they won't use it. So this was my situation as a digital research data manager in an analog project. And I tried to boil it down in terms of what we are able to collect, what we are able to collect in a not so costly fashion, and what time of training and support we could bring to the researchers. And we decided it should be simple, practical, and accessible. And the really most important thing was to figure out what is important to the researcher and when or how can we make them engage. And the most important thing for them is the publication. So if you somehow connect the process of research data management and of quality management with the publication, then you have a certain point where the data is at least is there and the quality is good because it's reviewed. And this is what we try to do. And we also only record the 4 most important data types, like images and figures, maps and georeferences, tables and statistics, and bibliographic references. We hired data steward for these data types because especially maps and georeferences need really specialized skills. So if you have the luxury of being able to afford data stewards for this kind of data, specifically do it because now we also change the way of how scientific figures are produced in the project. Like they were supposed to be done by an outside firm. Now we are actually doing this for the researchers, which is also a really cool thing being part of the research process for us. Then we offer a lot of free training, and we decided on offering the free training also to the rest of the department, because usually the people that are supposed to have training are not the ones who are getting it, but at least you can spread your wisdom with some like-minded people, and you get some feedback on how the knowledge that you expect people to have is actually spread. So how come from research data to public history? And we figured out that research data must be produced for a specific audience. You can't just take research data and expect it to work somewhere. Research data is always part of a data ecosystem, especially in the humanities, because we work closely with archives and libraries, and we need all the data or the sources from these institutions. Also, an important learning is that the public cannot be informed directly with research data. Like we need to use intermediaries. Like we are doing research and they're doing education. And it's a completely different business. And don't get me wrong, you're all really smart people, but educating people is really hard. And I think we should leave it to the professionals and just ask the professionals what they need from us. And this is also what we try to do, that we worked with 𝗟𝗻 institutions and ask them, how do you need research data that you, for example, can do an exhibition or can do a city tour or stuff like this? We have some insights from these surveys. It's stuff that you already know, stuff like you need a target group, that you actually can address. You need collaboration with existing providers because they will survive your project funding. You need to identify gaps within this ecosystem. This is a really fruitful approach because most of the time there's some little gaps that are quite easy to fill and have quite an impact. And I strongly advise, even though I come from a huge project, I strongly advise you do small projects, do rapid prototyping, and do ongoing monitoring of success. And aim for low technical and legal barriers because otherwise people won't be reusing your data. The best practices that we came up with is durability by design, openness and transparency, respect for user community, recognition of complexity, and sustainable resourcing. There's some repetition, like please just do what the ending principles tell you to do and use non-proprietary formats for data and metadata. And what is also quite important is that you need to be able to update your stuff afterwards. Think of that in advance. For example, releasing software as open source software on GitHub is not just uploading code. It's about caring about the community, reading issues, merging pull requests. Like there's a lot of work involving open sourcing software. So if you want to do it, you can't just do it 1 month before the project funding ends. You need to do it really, really from the get-go. Then be open, be transparent. This is something that people tend not to do because they are scared that they could fail. But I think failure is an important concept in research, and we should try to fail forward as much as we can. So just be open, have people engaging with your tools early on. Have respect for the user community, ask them what they want. And again, it's not only the end user, it's also the data producer, your teammates, and offer them support in terms of act as a data steward. Recognize complexity, because there are certain things that we will not be able to tackle because we lack the funding, or we lack the skills or the experience. But just make the things you do, try to think in terms of small, divisible working packages and not huge, integrated, complex projects, because they're prone to failure, complex systems. Allocate resources for digital preservation and ask other institutions whether they can help with that. And finally, there are some tools, but I already ran out of time, so I'm just shortly going to tell what we are doing. We built, or we use a research data platform in our project. This is still a clickable prototype, and it's built with like really simple and stupid software, 𝗟𝗲𝗴𝗹, CSV, Markdown. It's open source, and we work closely together with the University Library of Idaho. I highly recommend this if you want to open source or publish a small collection. This is a perfect tool. It just hammers out HTML, CSS, and JPEGs, and it will be accessible in 1,000 years, or I don't know. Then we are working on the portal. End of life is end of project funding. This is why I decided to go with SvelteKit, a framework that I especially like to code with. And we tried to integrate even there some long-term archival solutions. We used 𝗟𝗶𝗴𝗶𝘁𝗀, the French scientific blogging platform, which is done by the 𝗟𝗲𝗴𝗹𝗛𝗂 in Lyon, and it's a long time archived, so you don't have to worry, they do it. And we also open sourced the software, and we also hammer out minimal and static HTML, CSS homepages. And we do some data stories to try to do some public history ourselves. It's really hard because data stories tend to get really, really long. Yes, I think we need some help with that, but we are developing other stories that work more or less like a game. Then we worked on the scientific illustrations and devise a way on how to think of maps, for example, as boundary objects and how it can influence the research project. So that don't see a role, or the data steward role is not only a support unit, but can also become part of the research. And I strongly advise you to mix early on the data stewards with the researchers. And there's a lot of knowledge transfer that goes on and that makes research better and makes research data management easier. And then we work on guidelines for inclusive annotation of historical data. This is something that is astonishingly hard because we ran into the problem that certain standards they are structurally racist, like and discriminating. If you look at gemeinsame Normdatei, and you only have 3 gender options, male, female, and not known. Like, this is not something I want to use in the 21st century. So coming up with new vocabularies is hard, and it somehow breaks the compatibility with the old ones, but it's necessary. We want to do research data management that is perfect for the researchers, that allows them to do research on racism, on post-colonialism, and stuff like this. And last but not least, we have a template that you can also use for research data that integrates with Git and also with Zenodo, the long-time archival storage at CERN in Geneva. And it makes it quite easy to do the right thing. Like, it's mostly just a checklist, a to-do list of how to name stuff, what formats to use, and how to set up the metadata correctly. Thank you very much for your attention.